is going to discuss some algebra of functions. And we're going to learn some notation like this: f plus g, f minus g, f times g, f divided by g, and f composed with g. Now that last one, at some point we'll take a look in the book and see and understand what that is. But really, a good part of this section is just devoted to helping you learn some new notation. You can look on your book, or in your book on page 900, and see exactly what I mean. So let me kind of zoom in as best I can. F plus g, when f and g are functions, can be thought of as f plus g of x. And you're probably best off thinking of it like this: it's just f of x plus g of x. It's just a fancy way to ask you to add two functions. Likewise, f minus g has a couple similar notations, and it's a fancy way to ask you to subtract two functions and then multiply and divide. The one that's kind of strange, the one that we'll cover last, is function composition. And the symbols there look a little bit different. Here's your function composition. It looks like fog. Almost looks like an O. It's a little bit smaller, different font, but that's your function composition. That's where ultimately we're going to go in this section. For now, let's practice with this notation though. And we're going to do a couple problems. I'm going to modify them a little bit. They're going to give you, in problems 14 through 20, some functions, and I just want to make them a little bit more interesting. So let me zoom out a little bit, and it might help if I was focused on the right spot. So problems number 14 through 16, or 14 through 20, let's use f of x, or just f, as being 2x plus 1, and g of x, sometimes we'll just write it as g, is going to be x minus 3. So these are our two functions for the remaining four problems. We'll start by working problem number 14, which asks us to calculate f minus g. So f minus g is just asking you to subtract these two functions. It's going to be 2x plus 1 minus x minus 3. The one simple place that you can make a mistake, if you're not careful, is by not distributing the negative to both of those terms. So if I get rid of the parentheses, that's 2x plus 1 minus x plus 3. At this point, we can combine like terms and get x plus 4. And that's your answer. That's what they're looking for in problem number 14. But it's just some notation. Really, it's just asking you to find f of x minus g of x. That's all they're asking there in problem 14. Problem 16 asks you to find g plus f, which is essentially g of x plus f of x. All right, so g of x is x minus 3 plus 2x plus 1. And it's just a matter of adding like terms. So we'll get 3x minus 2. Can I give this one some love?
That was easy.
A couple easy points for you. Don't miss those kinds of problems on the exam. All right, I put them there. You had them on the one you just took today. Adding and subtracting complex numbers. Those were points that I really want you to have. So same thing with these. Don't miss them. The only place that people miss them is that they forget a negative sign when they distribute, or sometimes they FOIL. Now, in problem number 18, that's where we're going to end up having to FOIL. No, it's actually problem number 20. Problem number 18, we do f divided by g. So f divided by g, that's really f of x divided by g of x. So that's 2x minus 1, or excuse me, 2x plus 1 over x minus 3. Now they do ask you for a little bit more in this problem, or in this series of problems, and I haven't bothered with it until now. But this is a good follow-up to section 10.5. In problem number 18, they want to know what's the domain. So the domain is all real numbers except any number that's going to cause a problem. Can you see a number that's going to cause a problem when I plug it into f of x divided by g of x? 3. So your domain is everything but 3. And you can write that in a couple ways. You can say your domain is x not equal to 3. And I'm fine with that. You could write it in interval notation. So you could write negative infinity to 3 union 3 to infinity. Just make sure you use parentheses there and not a bracket because you don't want to include the 3. So again, basically everything but 3. Plugging in a 3 there, you'd be dividing by 0. Problem 20. G times f. So essentially, this is shorthand notation for g of x times f of x. You could also write it like this, g dot f of x. So that's an accepted version of this notation as well. Really what they're asking you to do is to multiply together these two binomials. So x minus 3 times 2x plus 1. How am I going to multiply those two binomials together? FOIL. Yeah, FOIL. So 2x squared plus x minus 6x minus 3. Combine like terms, 2x squared minus 5x minus 3. Now technically they asked for the domain in this one, but what would the domain be for problem number 20? Is there any value of x that's going to give you a 0 in the denominator? Or a negative underneath the square root? Or something that's going to create some problems? No. There's nothing that's going to create any problems. This is a polynomial, and they're defined for all real numbers. So negative infinity to infinity is your domain. And you can also write that like that with a script R. That's a horrible script R. Let's blot that out. Script R like that. Okay. So, kind of a warm up on some of this function notation. Yes, ma'am. All right, so there's two questions in problem number 18. The first one is just basically to calculate this, and there's really nothing to calculate, right? You're just dividing this divided by this. So you're just replacing f of x and g of x by their respective definitions. For the second part, what we want to avoid is where the denominator equals 0. So where does x minus 3 equal 0? When x equals 3. But we don't want that. So it's like everything but that. So you set the denominator equals 0 to solve, but then you throw that point out. That's the one that you don't want. Okay. Is that it? Getting at your question? Or I can make a more difficult problem to solve there for you if you want. No, but seriously. Something seems to be troubling you still, so what can I help with? I promise not to make it easy on an exam, okay? Just for you. We'll also get you an escort to your car after class. Because everyone's going to want to beat you up. I'm kidding. No, that's it. It's really that simple. It's just you can't put in a 3. I mean, if you were to plug this expression into your calculator and do a little table and then type in a 3, it would say error. Because your calculator won't let you divide by 0. Okay? All right. let's kind of build on that notation a little bit. We want to learn function composition notation. So function composition. Basically what you're going to do here is put two functions together to get a new function. You're trying to build functions. And this is done quite commonly. When you go scuba diving, what you have to worry about is too much nitrogen in your blood. Because if you get too much nitrogen, you literally get what are called narked. It's what the dentist does to you in the dentist's office. He gives you nitrogen oxide. You get this nice little warm glow of a feeling, which is great in the dentist's office when you're safe above water. But if you're well below water and you get narked and you get all giddy and you start passing your breathing mask to a fish that goes by, then you're going to be in trouble. And also, if you rise too fast, then you run into problems because you get the bends. Because all that nitrogen is coming out of your blood really quickly. It's like uncorking a pop bottle. You get all that fizz being released because the pressure is released. So scuba divers are very, very careful about their ascent and the nitrogen in their blood. The nitrogen in their blood is a function of their depth, because the depth tells you about the pressure. So when you put these things together, you can figure out how much pressure you are based on the depth. So you're putting two things together, and that's really what's going on with function composition. You're creating new functions by putting them together. So the notation looks like this: f of g of x. And I try and exaggerate that a little bit so that it doesn't look like a times. And when I do it with my software, when I write out your test, again, it's not going to look like a times, but you got to make sure you don't confuse it. Because what this really means, it means f of g of x. G's on the inside, f is on the outside. I could write it the other way around. G of f of x. And again, whatever comes first is going to be on the outside. G of f of x. So let's try a couple examples with this new kind of funky notation. The book's going to have to give you, or I'll have to give you, the actual functions involved. So we'll start with problem number 38. And we'll do a couple problems with 38 so that we can use the same pair of functions. F of x is 2x plus 1, and g of x is x squared minus 1. So we're going to use these same two functions for the next several problems. We'll start with problem number 38. G of f of 2. Now personally, when I see this notation, I get rid of it as fast as I can. I rewrite it as g of f of 2. Because this gives you a better idea of what we're going to start with. You're going to start with what's in the inside parentheses there. So we're going to start with f of 2. Let's figure out what f of 2 is. So let me do that down here. F of 2. Well, let's plug in 2 for x. What's f of 2 going to give me? 5. 2 times 2 plus 1 is 5. Okay. But if f of 2 is 5, that means I can rewrite my expression here. Instead of g of f of 2, what can I write? G of 5. And now I can look at the rule for g. The rule for g says, whatever you put in my parentheses, square it and then subtract 1. Okay. So 5 and 5. So I'm going to take that 5 there, square it and subtract 1. 25 minus 1 is 24. Yay. Let's try another one like that. Are you okay with our first example of function composition here? Let's try problem number 40 then. Same two functions. This time they want us to calculate f of g of negative 3. So f of g of negative 3. So again, work with those two functions up here. Yeah, that didn't work too good. When I rewrite this, Kyle, what goes on the inside? Good. So f of g of negative 3. And when I start to evaluate this, Lauren, where should I start? What should I start with? Perfect. So we're going to start with g of negative 3. G of negative 3, let's see. We're going to take something and square it and then subtract 1. So let's put in the negative 3 here. What's g of negative 3 going to give me? 9 minus 1 is 8. Great. So I can replace this with this. This becomes f of 8. Now you want to go to the rule for f. The rule for f says take 2 times x plus 1. So when I put in an 8 here, I'll put in an 8 here. What's f of 8? 17. And that's my final answer here. F of g of negative 3 is 17. So here's your final answer. Let's try problem, you know what, let me give you a problem before we do problem number 44. And we're going to continue working with the same two functions. Are you okay with these first two, 38 and 40? So let's try and find f of g of x. Now what's different about this one as opposed to our last couple? There's an important difference between this one and the last couple. Yeah, you got a variable here instead of a number. So that's going to change things a little bit. But we're still going to kind of proceed the same way. We're going to start out with replacing this. But what can I replace g of x with? X squared minus 1. Perfect. G of x is just x squared minus 1. I can use one or the other. They are the same. Now, let's go to the rule for f. The rule for f, going way back up here, is to take 2 times x plus 1. Well, instead of an x, what am I going to write? What do I have instead of my x? This whole expression. So 2 times x squared minus 1. And if you distribute, you get 2x squared minus 2. Does that 2 distribute to the 1 over here? Or is it just distributed to those two terms? Just those two. So 2x squared minus 2 plus 1, or better yet, 2x squared minus 1. Would it make a difference if I did it the other way around? If I did g of f of x? It could. In fact, it often does. G of f of x. Well, what could I put in here to start with? Kennedy? Good. F of x is 2x plus 1. So we'll put in that 2x plus 1 in place of f. Now let's go to the rule for g. The rule for g says take x, square it, and then subtract 1. So that means take 2x plus 1, square it, and then subtract 1. Now I'm kind of running around a room on my paper here, so let's just square this one out in our heads. That's going to be 4x squared plus 4x plus 1. When we square that, and we still have the minus 1 here. So, sorry I cheated you out of that demonstration. When we subtract, cancel the like terms, you should end up with 4x squared plus 4x as your final answer. So does the order make a difference, f of g of x and g of f of x? Are they giving us the same thing? No. You're getting something much different. So definitely make sure that you have the right order to your work, because it makes a huge difference. Generally speaking, these two things are going to be different. Sometimes really, really different. And that's fine. There is a special occasion that we'll talk about in the next section where these two things are going to be the same. Let's try a few more like that. We'll move up to problems like 58 and 64. And we've got a new function, or a new pair of functions to work with. So let me get those to you. So f of x is 3x minus 2. And g of x, x squared minus 1 again. No, wait, no, x squared plus x. X squared plus x. We'll start with problem number 64. F of g of x. So let's start by replacing g of x by x squared plus 1. Or excuse me, x squared plus x. So g of x fits nicely in here. Now what? Now go to the rule for f. The rule for f says take 3 times something and then subtract 2. Abdulaziz, what number am I going to put in here? Or what expression am I going to put in here? Yeah, x squared plus x. When you do that, the only thing left that we can do is distribute the 3. 3x squared plus 3x minus 2. And that's it. Done with that one. What if we tried it the other way? let's just do it the other way. It's not part of problem 64, but let's just do it the other way just to see. G of f of x. Where should I start? Gil, suggestions? Good. So instead of f of x, we can put in 3x minus 2. So let's do that. So be 3x minus 2. Now let's go to the rule for g of x. The rule for g of x says whatever you put in these parentheses, you're going to square it and then add x. So square it and then add itself. So that means you're going to take 3x minus 2 and square it, and then add 3x minus 2. All right, I've got more room. Do you want me to square that one out, or can we do it in our heads? Let me just share with you the trick doing it in your heads, so that maybe you can do it as well. Bless you. When you have a minus b squared or a plus b, doesn't really matter so much. When you FOIL that out, when you do a minus b times a minus b, you're going to get a squared, and you're going to get that middle product twice. And the last one's going to be the square of the ends. So you're going to get both the end terms squared, and then in the middle, you're always going to get 2 times a times b. So what I do is I kind of borrow this 2. I go, all right, 2 times this times this. And that's how I come up with that middle term. So for instance, in this one, when we square 3x, what do you get? 9x squared. When you square 2, we get a plus 4. Now 2 times this, well, 2 times this is 6x times negative 2. 6x times negative 2 is negative 12x. There you go. So it's great if you can do that. I wouldn't suggest you do that unless you're comfortable with it. But if you can do that, it's a nice trick. It's going to shorten up a lot of your work. Kara, last thing we need to do here is add like terms. Good? These are opposite in sign, though, I think. Mm-hmm. Again, these are opposite in sign. There you go, plus 2. All right, thank you. So again, much different when we do it this way as opposed to the other way. So if you compare g of f of x, which is right here, to f of g of x, they don't look anything like each other. You have to take care of which way you put these in to your functions. It was, well, the form of the function for g of x is x squared plus x. So I had to plug in one here and the other one here. So I had to plug this into 2 different places. Into here for x and into here for x. So it got plugged into both of them. Something. Okay. All right. Any other thoughts on our extended version of problem 64? No. There's like 15 minutes left in class. You would not ask a question on your life. Like, no, get me out of here. Okay. Well, we're getting really close. Let's do problem 48. I like problem 48. There's really no calculation in problem 48. Can you believe that? I got some property in Florida for you too. It's in the Everglades, right? All right. Um, yeah. Well, actually, parts of Nevada, I think, will have oceanfront property, but that's in quite a few million years when plate tectonics moves Madagascar out in the Pacific, like, or I mean, moves California out in the Pacific like Madagascar. All right, so let's do part B here. And I like this one. So the first thing we have to do is unravel this notation. We've got g of f of 4. So let me rewrite it down here. G of f of 4. And as kind of usual, we're going to start out with the inside part, right? G of 4. So G of 4, no, excuse me, not, I said G of 4. F of 4. F of 4. How am I going to find f of 4 from this graph? What is f of 4? Well, how do you find the value of a function? Well, you plug it in the function and you do the calculation. If we can't do that, then we can look at the graph. Here's x equal 4. Here's the function for f. What's the y coordinate at x equal 4? 2. Can you see that? At 4, you get 2. So instead of g of f of 4, I could write g of 2. So now I'm going to look at the other graph and try and find g of 2. So, Mackenzie, what's g of 2 going to equal, please? G of 2 would be negative 3. Good. All right, so kind of a nice one. I mean, it's just, there's really no calculation there. It's a friendlier one. Let's try another one like that. Part C. F of g of 6. So f of g of 6. Now, I'll be honest with you. You're going to have to kind of estimate this one a little bit. And I'd probably be a little bit more careful than that to give you a problem that you need to estimate. The first part should work out pretty even though. G of 6. In fact, I got a great idea. Let me give you the homework. And what I want from you before you leave is the correct answer to this problem. And then you can leave. So we'll be all done. So for homework, try problems 13 through 47, 57 through 63, and 77 through 81. Now I've got a note here, bonus 49 through 55. So yeah, once again, 13 through 47, 57 through 63, 77 through 81. Okay, so when you get the right answer, come on up and show it to me, and then leave. See ya.